Hello and welcome everybody. Today I want to just chill and learn a little bit pandas with you. We start this tutorial by just importing pandas as PD. What I can do now is I can say PD and this will give me access to pandas. The most important thing about pandas is the data frame. So I will access it by saying pd.dataframe. This is, as I said, the core thing in pandas. So if I now put parentheses here and execute it, you will see nothing because this is now an empty data frame. So basically a table without any content. So let's fill it up with content. For that I will just use a dictionary, which is a common data structure in Python. I just say dict and then for example a is equal to 1, 2, 3. Perfect. And now that I have this dictionary of a as a key and then the values 1, 2, 3, I can execute it and get this nice table. As you can see, it has columns, or right now one column A, and rows 0, 1 and 2 right now. I could add here another column, for example like this, and then give it other values, for example 4, 5 and 6. Execute again, and now I have 2 columns and multiple rows. Now this is just one example of how you can create your data frame, but usually you will load in your data frames from somewhere. For example, you might say pd.read underscore, and now you have multiple options. So if I click on tab, it will give me multiple options now. So for example, I could read from the clipboard actually, which I wouldn't recommend because it's not really reproducible. I could read from a CSV or an Excel, which are, I think, the most common things for people who are beginning. Feather and other data structures, HDF, are maybe more advanced or for special use cases, so let's not think about them too much. But for example, I could say read CSV, then put parentheses here, put in the path to the file and load it in. But instead what we will do is, we will get a data frame from another library because I want you to be able to follow along. And for this we will use Seaborn. From Seaborn, import load dataset. And this is just an example, you don't need this, but it's an easy way to get to some datasets. So for example, I will now load the iris dataset here. As you can see here, this is now a nice data frame as we already know it. So now I will save it. Often we start the names of variables from pandas data frames with df underscore and then some name. For example, this is the iris dataset, so I will call it df iris. Perfect. So now I have the data frame. I can look at it, for example, by just saying df iris here, and then I will see the complete data frame. As you can see here, there are some points in between. This just means there are some values that are not shown. You can change in pandas very easily how many values are shown. Maybe I will show that later in a tutorial, but for now this is good enough. But what you can do is, if you only want to look at the first couple of rows, you can say head, then it only prints the first 5 rows, so 0 up until 4. You can also specify a number. For example, if I say 10, it will be the first 10 ones. Or I can also say, instead of head, tail. And with tail I will get the last ones. Nice. So we've already understood that we have columns and rows, and each combination has exactly one value, and we can show right now the first couple of rows or the last couple of rows. Now you might ask yourself, how can I access now one column at a time? So one specific column. There are many ways to doing it. One is, or the easiest is, to say just the name of your data frame, so iris. Then you put in brackets and the name of the column. You put this into a string, so here it is sepa length, and now you will get the column. This column is now not a data frame, as you can see, but a series. So if I say type, which is just a Python function to always show the type of the object you're looking at, you will see this is now a pandas core series, not as before a pandas core data frame. So for example, if I say here type df iris, this was a data frame. And you can just imagine it as following. You always have a data frame if you have multiple columns and multiple rows, and you always have only a series if you only have one column or only one row. So the idea is a series is just one series of values with an index, and a data frame are multiple series of data who share an index. So for example, here I have the series for sepal length with the same index as for sepal width. And I could also say it the other way around. For the row 140, I could have all of these as an index, and these would be the same as for the row 141. Okay, so now we know how we actually do this. But how can we get multiple columns? Well, that's actually as easy as getting one. Instead of providing now one name, I'm providing multiple names. And to provide multiple names to the bracket, I give it a list. A list always starts with its own bracket, so we have two brackets now. So df iris, two brackets, and then one column name and another column name. We close our brackets and hit enter, or shift enter. And now you have both of these. Nice. By the way, there are other ways to get in columns. Something that might be very nice, especially if you want to get to one column, is that you can also just write the name of your data frame, df iris, then dot, and your column name. As you can see, here again we get one series as an answer. If you want to have one data frame with just one column, you can, by the way, also just use this. The idea is, as we discussed before, that if you give two brackets, you're giving a list of columns to the data frame. As this is a list, even though it has only one entry, it will return a data frame. Okay. So now we know with a couple of tangents how we can get to our columns. But how do we get to our indices? And here I would now suggest that you always use the .log attribute. So if I say df iris and then say .log, what we will get is an indexing object from Pandas. And this makes your life much easier, because now you can give it again the brackets as before. And now you give it first the indices you want. For example, let's say I want 0, 1, 2. So a list of 0, 1, 2 for the indices, and then a list, or let's just do one first, of sepal width. I'm closing the bracket, I'm executing, and what I'm getting now is a series as an answer of having the index 0, 1, 2 and one column. The index name, or the series name, by the way, is a column name. If I would have provided here multiple columns, or the column as a list, then I will get again a data frame. So this looks complicated, but it's actually very easy and only doing what we've done before. So we just say .log, and then we can access with a bracket first the indices, comma, and then the columns. Both things can be either a list or just one value. So for example, if I would have said 0 here, I would get these columns, sepal width, sepal length, but just for this index. And this is again, of course, a series, as we only have one index. If we would have a list of indices, then you can imagine what happens. As we've seen before, a list of indices, even if there is just one entry, will return a data frame of the same information. So this is actually very easy, and don't worry, if you need to look this up, you can do that. One last concept about indexing. Right now we are indexing by the name of the index or the columns. So we are actually saying 0 here, and here is also a 0. Or here we are saying the name of the column. You can also, instead of using the names, using the index itself, so the number where it is. So for example, if I say df iris, and now I say ilog for the index location, then I can again give it, for example, the 0th index, and now I want the 0th column and the first column. And this will return now the series with these column names and this value. Let's make it a data frame to make it a little bit easier to understand maybe. So 0 index, or the 0th index, so at number 0, and then this 0 number and the first number of the columns. Now you might ask yourself, why are we doing this for the index, right? It's exactly the same. We are doing this because the index actually in Pandas can be something else than a number, or it can start with 2 or 3. Let's look into this. So if I'm having here the df iris, right? I can say, just give me the index. And now we see, wow, the index is starting at 0, it's stopping at 150, and has a step of 1. How about we change that? So for example, I can say, let's give this a range. It's just a Python object. Now we start at 1, we go to 151 in steps of 1. If I'm executing this, now I can look at my df iris data frame and see we still have 150 rows and 5 columns. But we are starting now at 1, not at 0. And we are ending at 150, not at 149. This means now, if I'm doing the ilog, it will still go to these values of 5.1 and 3.5, right? Because it's still at number 0, even though the index is 1. I will execute it, and you will see same values. The index changed, but the values are the same. If I'm here running this one, right, where we are getting to the actual value of 0 for the index, you will see that it will now actually fail, because there is no 0 index anymore. There's only an index at the 0th place, let's say, right? So if I change this to 1, now I get the same values. In general, I would usually use log and make sure that my indices go from 0 to then the last one, and then it's always the same and all is good. But just that you know, both of these things exist. I'll just grab a little bit of my tea and then I will continue with you. Okay, nice. Now that we've understood this, we can continue and have a little bit more fun, because everything until now were very, very basics. Now let's have fun. So first of all, I will reset our index, okay? So in Pandas you can always say the name of your data frame, so far as df iris, and then reset index parentheses, and then what you get is your data frame with a new index starting at 0 going up until the end. You get the old index as a new column, which I don't want, so I will just say drop equals to true. And this will now create the df iris without the old index but with a new one. Just that you know, this will not be saved if I just do this, right? So if I say df iris again, it will still look as before. But if I say df iris equals to it, then I will assign it or override it to be again as we want to. Another option is that sometimes in these methods from Pandas you have something called in place, and if you set this to true, then it will also change the df iris without assigning it, so without doing this. I personally prefer to do this because it's more explicit and it always works, and the in place thing needs to be implemented in the method. But both is fine, both works very well. Okay, so now we have our data frame and now we can have fun, as I said before. So what can we do funny things? We can of course, from the data frame itself, just let it give us some information about itself. This is not so interesting yet, but it can say stuff like, okay, we have these many columns, we have these many values for these, some are floating numbers, some are objects which are strings and things like these, so letters, while floats are a specific type of numbers with like decimal points. We can also say df iris and describe yourself. And this is very interesting because describe gives us an overview for all columns which are numeric, right? So floats and ints, and gives us the mean, the standard deviation, the minimum, some of the quantiles, and the maximum. So some nice descriptive statistics. You can also always do these things just on one of the columns. So we just access one column. For example, can take super length, and then I can say please describe and get all of the information. Of course, if I just want one of these values, I can also get those. df iris, and now give me this column, right? We said we can also say dot column name, at least as long as they are only without spaces and stuff like this, right? And then I can say just give me the mean. And that works, and as you can see, it's exactly the same. I can also say this value should be rounded. Maybe that was a little bit much, so let's round it up until the second decimal place. And what we can see now is that you can put a lot of these methods here behind each other and get to nice results. Okay, you can of course also get other things, like for example the median. That works as well. Here the median and the mean seem to be quite close. Like here we can see that as well, right? The 50% is also the median, of course. I can get the max, I can get the min, I can get the mode, or maybe even the variance. All of these things work. So you can always take your column and just use one of these methods on them. You could also compute them yourself, of course. So let's try that for a second. So the nice thing about Pandas is you can take columns and you can just add them, subtract them, and do whatever. So for example, let's say I'm taking this column. Now I'm subtracting from it the mean. Right, now I get the values minus the mean. We could also try this out. So for example, if here I say df iris and just give me the first couple of values, right, with head, I can see it's 5.1, right? So the first value has to be 5.1 minus the mean. The mean we said is 5.84. So this makes sense why we are getting to something like 7.4, like minus 0.74. Nice. Now we are taking this. Now we are getting the squared deviation from each value to the mean. And now that we have this, we can sum them all up. So we just put another parentheses in here, which now means that first we had one series and we subtracted another series mean of it. We got as an output a new series. This series we want to now do something with, so we put parentheses over it. So we are not accessing this series, but the output of them. That's why I put the parentheses. And then we square them, getting again new output, right? That was this output. Now to change this output, I can put again parentheses over it. And now I can sum them all up. Divide them by the number of data points we have. So this is the length of the iris dataset. And this will give us a variance of 0.68, which is also what we get here. We have slightly different values. These are probably just rounding errors, but you can see this works. And also we've learned something new. We can get the length of a data frame like this, which gives us 150, which is all the rows we have. The length of a data frame are all the rows. If I get the length of one column, I get the same thing, of course. But what I can do is I can take the data frame, just say shape, and it gives me again all the indices, so the number of indices, the length, and how many columns we have. The really interesting thing you've now seen is that we can use Pandas to compute really interesting things. All of that works in a vectorized way. So we don't have to loop through the data frame, we just use something like subtraction, a multiplication, or the power to, and this is how we can compute a lot of things. Of course, this is not the only thing we could have done. We could have done this in a much more elegant way, which I will maybe show you later. But for now, let's look at a couple of other things. Let's go back to the topic of filtering actually, but now do it in a conditional way. So for example, we have here this species values. Now first, before we can filter for them, let's look at what species values do we have. We can do it with df_iris and then give me the unique values. Of course, we cannot get the unique values of the complete data frame, but of one column, so the species. And now you get all the unique values, right? This is setosa, versicolor, and virginica. You can also just say n unique, which gives you directly the answer that you have 3 unique values for this one column, right? So we are going to one column, and then we are saying, give me all the unique values or the number of unique. What I personally like most is the following. Instead of saying unique, we are just saying, give me the value counts. And these value counts now actually even work on a data frame, but we only want to look at the species. Gives you now all of the values and how often they occur. So we have 50 times setosa, 50 times versicolor, and 50 times virginica. You could even say stuff like, please normalize it. Which means now, instead of giving you absolute values, it gives you the percentage. So each of them are roughly 33% of the data. By the way, if you ever ask yourself, what arguments do I have for a method, you can just take the method and put a question mark in front of it in a Jupyter notebook. And this will now give you all the information about it. These are all the parameters. So normalized, you've just seen it. We can sort it or not sort it. It can be ascending or descendingly sorted. We can use bins if we want to, or, and this is very important, we could decide to not drop missing numbers. Missing numbers are a completely own topic. We will not touch too much today, but it's important to say that in Pandas, by default, missing numbers are often ignored, which is maybe not what you want to do. So I just wanted to mention it. Okay, so what we wanted to actually do is we wanted to filter our data, so our data frame, to only have some of these values. So for example, we only want to look at the data frame where species is equal to setosa. How could we do it? One way would be to say we are getting species, and then we are just saying this should be equal to setosa. And this will give us now a series as output with the same index and just a boolean, so true or false. It will be true where this condition is met and false where it's not met. And the nice thing is, this series can now be used to actually index our data frame. So we can just say df_iris and then index with that. And automatically it will understand that it should index only to give us setosa. Personally, I would prefer to still use .log and say I want to change the indices and I want to get all the columns. This is a little bit more explicit, but basically it means the same thing, right? So just one new thing we've learned is we can use these double points to say everything. But I could have also said I only want to look at the petal width. Nice. Okay, this is one way of doing it. Another way I really like is using query. The nice thing here is I can just use very normal language and say query where species is equal to setosa. Just close it up and it will return the same answer if I close the string. I really like this because it's much simpler, simpler to write, right? Here I just say query and then I give it a string where I just say my condition. Over here I had to write the condition into brackets and I had to say twice df_iris. If I now make the condition more complicated, this will get even better. So for example, here I can say I'm now looking at a query where I'm not only having one condition, but two conditions. So I have the first condition, put parentheses over it, then I say add for and. Second condition is that sepal length should be bigger than, let's say, 4. I close my parentheses, I run it, and now what you will see is sepal length will always be bigger than 4. I could also say, for example, bigger than 5, then it's maybe easier to see. And this is quite easy to write. If I would use this notation, it would look as following. Let's get rid of the log for now because it just makes it more complicated. Parentheses and parentheses df iris dot sepal length is bigger than 5. Closing it up and running it again. So it's not that big of a difference, of course, but I prefer to not write so often the name of the data frame. But both works fine. So this is how we can select for a condition of one column. So if one column is equal to this condition, then I can select all the rows which met this condition. If you want to select columns instead, another nice thing is you can say something like this, df iris, and now filter. And for filter, let me also get again all the options. And here you can say like items, so you can give it explicit items. But what I really like is the like option or the regex. The regex is for if you know how to use regex, then go with that. And the like is an easier way of doing it. So for example, I can say in the filter, like sepal, close parentheses, not use a question mark, and now it will select all the columns which are like sepal, so sepal length and sepal width. This is a little bit magical. Using regexes would be more reliable, but if you just want to look at something quickly, this works as well. Well, and I mean, this is already a lot that we have learned, right? So we have learned a lot about indexing, a little bit of conditional subsetting. We worked a little bit with computations in Pandas, and the nice thing is there's much more to learn. I would just say have a nice day, and maybe we see each other again in another video. Drink a little bit tea, relax, and learn more about Pandas. Bye!